provided one of the most detailed maps of the CMB. However, there is still disagreement among researchers as to how this data should be interpreted. While some claim to have found the necessary evidence for the Big Bang in the CMB, what happened to Voyager 1? According to NASA, the probe is sending a strange signal from interstellar space. Could this be the first indication of an encounter of the third kind, or are we just dealing with a technical fault? Never before has a probe been in interstellar space. Voyager 1 is the first man-made object to send data from there, and it's confusing. What if the interstellar medium is completely different from what scientists previously thought? Will we then have to rewrite the textbooks and prepare ourselves for further discoveries that challenge our imagination? Imagine how a brave probe has been traveling through space for more than 40 years and has now wandered far beyond the boundaries of our solar system. Then suddenly, the probe begins to send a mysterious and inexplicable sequence of signals to Earth. Voyager 1, the furthest man-made object from Earth, transmitted a strange sequence of ones and zeros to Earth almost half a century after its launch. What had happened? The binary code was designed in a pattern that made no recognizable sense to the scientists. All at once, the NASA scientists and engineers were faced with a puzzle. Had Voyager encountered something strange, or was the probe just broken? The second problem was how to diagnose and fix a problem when the device was 24 billion kilometers away in interstellar space. The situation surrounding Voyager 1 presented NASA with a lot of challenges. When the NASA control team first learned of the unusual signals from the Voyager 1 probe, the feverish search for solutions began. They began to analyze the structure of the mysterious messages, hoping to discover in the pattern a clue to the underlying disturbance. The problem appeared complex, so the NASA team turned to artificial intelligence to help them sift through the data patterns using a specialized algorithm. The AI became a crucial tool in deciphering the signals. After days of intensive data analysis, a recurring pattern was recognized, and this was the first indication of a malfunction in the probe's communication hardware. The team developed a hypothesis that a defect in the telemetry modulation unit, the device responsible for converting and sending data from the probe to Earth, could be the cause of the distorted signals. The next challenge was to find a solution to fix this defect remotely. To understand the technical details, engineers dug out ancient blueprints from the archives. Some of the data had long since disappeared or been destroyed, so even former NASA engineers who had long since retired were called back in to solve Voyager's problem. After several simulations and tests, the team decided on a bold approach. They tried to instruct the probe to switch to a previously unused communication system that had long ago been programmed as a backup for just such emergencies. This operation was dangerous because this measure could have meant the end of communication with Voyager. That a mission of a century would have ended sooner than anyone had hoped. Holding their breath, the team sent the order to switch over the communication systems, and then the long wait began. Due to the enormous distances involved, a signal now takes over 17 hours to reach the probe, and another 17 hours to return. We can all well imagine the tension in NASA's control room and the joy when Voyager 1 responded. It was a moment of collective relief and joy that will go down in NASA history forever. The spacecraft had successfully received and implemented the command, and the data began to flow again in an intelligible format. The mission could continue further into space than ever before. It's magical. The solution to the problem will give us years more of data from a space that has not yet been explored. Voyager offers us the unique opportunity to receive measurement data from the infinite space between the stars and planetary systems for the first time. The Voyager mission is truly one of the boldest space exploration missions we humans have ever launched. The primary scientific objectives of the Voyager mission in the near future include the ongoing study of interstellar space. Voyager 1 and its sister ship Voyager 2 are the only man-made objects that have ever ventured into this unexplored realm. The further away the probes are from Earth, the more exciting but also the more difficult the mission becomes. It is already a miracle that we can maintain contact with technical devices that are so far away. The second critical point is the energy supply. The plutonium-based radioisotope generators on board the probes produce less and less energy over time. The mission teams have already switched off most of the instruments in order to reserve the remaining energy for the most important scientific missions. NASA is currently hoping that both Voyager probes will continue to transmit data until the end of the decade and possibly beyond. But even when the radio link has long since been lost, the mission will not end. The Voyager twins will then become ambassadors for our civilization and culture. Each probe is equipped with an extremely long-lasting golden record on board, which contains sounds, images, and messages from Earth. In many thousands of years, the probes may be captured by the gravitational pull of a star and then appear on the radar screens of another civilization. Voyager. Fast, cheap, reliable. It's hard to believe, but these two veterans of space exploration were put together in a few months on a mini budget to take advantage of a special window in the constellation of the outer planets. Saturn, Jupiter, Uranus, and Neptune had not been so favorably aligned for 170 years, and it was known in the 70s that it would take another 170 years for the four outer planets to come together again. So they took action and built the two Voyager probes in a rush. Both were to take slightly different courses, and if one was lost, the other would still have been there. In the end, both reached their destination. 1977 was the beginning of an epic journey. To increase their speed, both probes flew several maneuvers around planets. Voyager 2, launched on August 12, 1977, reached Jupiter on July 9, 1979. Voyager 1, which followed on September 5th of the same year, reached Jupiter in March 1979 and provided the first breathtaking images and valuable data about the giant planet and its moons. One of the most remarkable results was the discovery of volcanic activity on the moon Io. At the time, this was the first observation of volcanism outside the Earth. After the successful flyby of Jupiter, Voyager 1 continued its journey and reached Saturn in November 1980, revealing the complex structure and beauty of Saturn's rings and providing fascinating insights into the planet's atmosphere and moons, as well as the first detailed look at Titan, Saturn's largest moon. Voyager 2 investigated the aspects around Jupiter that Voyager 1 had missed. Together, the two provided a perfect picture of the gas giant and so many images that scientists still rave about today. Voyager 2 visited Saturn and continued its unique journey to Uranus and Neptune. During its flyby of Uranus in January 1986, Voyager 2 discovered 10 new moons and 2 new rings around the ice giant. The journey culminated in August 1989, when Voyager 2 became the first probe to fly past Neptune and send us the very first image of the planet. Voyager 2 discovered Neptune's Great Dark Spot, many clues to the most violent storms in the solar system, and previously unknown moons. After providing invaluable insights into the outer planets, the Voyager probes continued their journey beyond the confines of the known solar system. Their mission was extended to an interstellar mission, and NASA was amazed at the tenacity and reliability these two simple probes had shown up to that point. No one had initially hoped that the two would eventually reach the boundaries of the solar system, but they did, and researchers are very grateful for these moving moments. The first time in the heliosphere. It was a cause for celebration. Voyager 1 reached the heliosphere in August 2012. The enormous bubble in interstellar space created by the solar wind, the stream of charged particles emitted by the sun, envelops our solar system and protects it from cosmic radiation. The boundary of the heliosphere, where the solar wind meets the interstellar medium and loses velocity, is called the heliopause. Beyond this boundary, the influence of interstellar space begins. Compared to the incredible vastness of the universe, the heliosphere is only a tiny dot. However, it extends far beyond the outermost planets of our solar system. Voyager 1 was the first probe to cross the heliopause and entered interstellar space in 2012, about 121 astronomical units away from the Sun, the equivalent of around 18 billion kilometers. Although this is an enormous distance from our point of view, it's small compared to the size of our galaxy. The Milky Way has a diameter